So I've put these exam questions for you on Show My Homework, and in this video I'm going to go through the answers. Ideally, I want you to pause the video at this point and do the questions yourself first, and once you've attempted all the questions, then press play again and go through the answers. So in the first question, you are asked to draw a reaction profile diagram. You are told that the reaction is exothermic. Because it's exothermic, I know that energy is released. And if energy is being released, then the products will have less energy than the reactants did. Therefore, I'm going to draw my reactants up here. And I'm going to draw my line for my products lower than the line for my reactants. And that gets you your first mark, just drawing the products to the right and drawing it lower than the line for the reactants. It asks you to identify the activation energy. So to complete my diagram, I'm going to have to draw that little hill. Okay, remember the activation energy is just the minimum amount of energy required. So in order for the reactants to become products, you need to first put some energy in, then they can react and they can form the products. And you get your final mark for labeling that activation energy. And when you're labeling, it's really important that you are starting your arrow at the reactants, not down at the products. So be specific with your arrow. That's what your arrow should look like. And all of that is 3 marks. And the next question is one of these energy change calculation questions. So they talk about 1 mole of gas and 1 mole of chlorine gas and 2 moles. Okay, you can ignore the word mole for the moment. We haven't looked at moles yet. It doesn't affect how you're going to do the question. It's going to be exactly the same as the other ones. So if I draw out hydrogen and chlorine, okay, it's just 1 hydrogen-hydrogen bond, and you've got a chlorine-chlorine bond. And then HCl is just going to have a single bond between hydrogen and chlorine. So the bonds that I need to break, I've got 1 hydrogen-hydrogen bond to break and 1 chlorine-chlorine bond to break. And I get the values for the amount of energy required to break those bonds right up there. And I add it together and I get 679. On the other side, I've got hydrogen chloride, which consists of a hydrogen-chlorine bond, but you're making 2 molecules of hydrogen chloride, so you're going to multiply that value, 432, by 2, and you're going to get 864. To calculate then your total energy change, it's going to be 679, your reactants, minus your products, 864, and you end up with, I think it's minus 864, you end up with minus 185. Okay, that tells me it's an exothermic reaction. So you are asked to just calculate the energy change, which we have done. So you'll get a mark for calculating this value, you'll get another mark for calculating this value, you'll get a mark for plugging these numbers into this equation, and then you'll get a mark for having your final answer of minus 185. The next one, you're given a reaction, tells you the temperature at the start, the temperature at the end. How do these results show that the reaction is exothermic? You will say the temperature has increased. So the temperature is increasing. You're going from 23 to 24.7. Therefore, heat is released. And if heat is being released, heat energy is being released, it's an exothermic reaction. The next one, again, you're asked to draw a reaction profile diagram. Again, it's exothermic, so this is going to be the same as my other one. You're not asked, anyway, on the expo, draw labeled lines. So you just have to label the lines. You're not asked to label the activation energy, which is why it is 2 marks instead of 3. But if you wanted to throw in labels, your activation energy will be there. And if they asked you for energy change, to label the energy change, you would go from the products up to the reactants, and that would be energy change. They haven't asked for it, but if they did, that's where you would label it. The next question, how can you improve this experiment if the temperature rise was closer to the expected? Went through this in a previous video. Use a polystyrene cup. So you can mention a polystyrene cup, you can mention putting on a lid, anything that's going to insulate and stop heat loss is going to improve the experiment. Which row of the table shows the heat energy change that occur? Okay, so when bonds are broken, we said you need to put energy in to break bonds. So when you're breaking bonds, energy is required to break bonds. So it has to be either C or D. And then when bonds are formed, we said energy is released. So your answer is going to be C. When you're breaking bonds, that requires energy. When you make bonds, you are releasing energy. C is your answer. The last question is another one of these calculation questions. So they've given you your equation up here. I've drawn all of these for you. So CH4 looks like this. Then you've got Cl2. Then you've got C bonded to 3 hydrogens and 1 chlorine. And then you've got a HCl. If I look at all the bonds I need to break, I've got 1, 2, 3, 4 CH bonds to break. And I've got 1 Cl-Cl bond. Using the values from my table, I work out a value of 1895 as the total energy required to break all of these bonds. If I look at my bond making, I see I've got 1, 2, 3 carbon-hydrogen bonds to make. I have got 1 carbon-chlorine bond to make, and I've also got a hydrogen-chlorine bond to make. So using the values from my table, I add all that up and I get 2017. To calculate my total energy change, it's 1895 minus 2017, and you get a value of minus 122, and that is kilojoules. They also ask you in the question to state whether this is endothermic or exothermic, and because it's negatively charged, you're going to say it's exothermic. They do ask you to state a reason, okay? If you are, specifically asked to state a reason, well, your reason is going to be more energy was released through making bonds than was required to break bonds. In other words, this value here for making bonds was higher than this value here for breaking bonds. Therefore, energy is going to be released and it's going to be an exothermic reaction. They are the standard questions you get in energy changes. You typically get one of those calculation questions to do. You might get asked a question about something along the lines of the polystyrene cup, and you're asked to draw these reaction profile diagrams. If you've got any problems with any of it, because I know it is a brand new topic, please just message me on Show My Homework or email me and I will help you out.